Next, the mass of a bottle half filled with water is 1.5 kg. Half filled means half. The mass of the bottle when it is 1/6 filled with water is 900 grams. Find the mass of the bottle when it is 2/3 filled with water. So we have three fractions right here, but they all have different denominator. So we want to make them the same denominator so that it's easier for us. So what's the lowest common multiple? It's actually 6. So how do I get 6? So this is 2, this is 6, this is 3, right? So you just list out the multiples of 2, multiples of 6, multiples of 3. So 2, 4, 6, 8, something, something, 6, 12, something, something, 3, 6, 9, something, something, something. So you can see that the lowest common multiple is actually 6. So we'll make the denominator to be 6. So to make it 6, here must times 3. Bottom times 3, top also must times 3. Yes, to even things up. This is already 6. For this, 2/3, to make it to be of a denominator 6, you times 2 times 2. So it's 4/6. Okay, so now we have all this information. How we draw things out. So this is my bottle. Since denominator is 6, I can split into 6 parts. 1, 2, 3, 4, 5, 6. I have a bottle. I have 6 markings on the bottle. So I know your bottle, you have different markings, right? But now I have 6 different markings on the bottle. So the mass of the bottle, when it is half filled with water, which is 3/6 filled with water, is 1.5 kg. So if the water level is at the third level, right, the mass is 1.5 kg. Then when it is 1/6 filled with water, so when the water level is at the first marking, the mass is actually 900 grams. Okay, so firstly, also after we label all of those, we can also see that the units are different. So let's just convert the units very quickly. 1 kg is 1000 grams. So to convert from kg to gram, we times 1000. The reverse is to divide by 1000. This will use the forward direction. Kg to gram. So 1.5 kg is 1.5 times 1000 gram. So if you times, you just have to move the decimal point to the right. So there's 3 zeros here. You'll move the decimal point to the right by 3 times. 1, 2, 3. Decimal point will be here, fill up the zeros. So it's 1500 gram. So I will just erase things to make things less messy. So 1.5 kg, we define on is 1500 gram. Okay, so now they want you to find the mass of the bottle when it's 2/3 filled with water. So what happens to the mass when the water level is at the 4th marking? Because 4th out of the 6th marking. So this is the question mark we need to find. So can you see that if we take 1500 gram minus 900 gram, we can find out how much 2/6 water weigh. So 2/6 water actually weighs 1500 minus 900 gram. And that will give you 600 gram. So then we can go and find out what 1/6 water weighs. So it's just 600 divided by 2, which is 300 gram. So for just every water, for every 1/6 water, it weighs 300 gram. Okay, so now we want to find the mass of the bottle when it's 2/3 filled with water. So we want to find out the mass of the bottle plus 4/6 water. So in this case, water must be included. That's something that you have to remember. So if water plus 3/6 gives you 1500, and you want to find 4/6, we just have to take 1500 plus this 300 gram of water, right? Then you can just find water plus 4/6 water. So it's just 1500 plus 300, which equates to 1800 grams. Okay, but the question wants it in kg. So look at the units. So what's 1800 grams in kg, right? So this time we'll use the reverse direction. So from gram to kg, we have to divide it by 1000. So 1800. So 1800 divided by 1000. So to divide it by 1000, we'll move the decimal point to the left-hand side 3 times because there are 3 zeros. And that will give us 1.8 kg. And the answer is 1.8 kg.